Hello friends, welcome back to the tutorial. In this tutorial, we will study how can we represent a finite automata. We can represent a finite automata graphically also. When we represent it by a graph, then that graph is called transition diagram or transition graph. Nodes of that graph represents states of finite automata, and directed edges are labeled with input symbol. These directed edges, which are labeled with the input symbol, represents transition. Here Q1, Q2, Q3 and Q4. These nodes of graph, or we can say of transition graph or transition diagram, represents 4 states of finite automata. And these arrows represent transitions. Now consider this arrow. It is labeled with A. Now it is from Q1 to Q2. It means when the machine is in state Q1 and it reads a symbol A, it will jump to state Q2 in a graphical form. Now we have to represent a finite automata graphically. Initial state is represented like this. Suppose Q1 is initial state, then we will put an arrow before it. Alright, here Q1 is initial state. Now second thing is transitions. Transitions are represented by arrows. Suppose there is a transition delta Q1 A equals to Q2. It means machine on from state Q1 on reading an input symbol A will transits to Q2. Graphically we can represent it by an arrow. And we will label this arrow by input symbol. A is input symbol. It means on reading input, machine will jump from Q1 to Q2. Next is final state. How will we represent final state graphically? We will represent graphically final state by encircling the node. Suppose Q3 is final state. Then we will encircle this node. So here Q3 is final state. So let us complete this automata. P, E. So in this automata, Q1 is initial state and Q3 is final state. As I have already told you, final states can be one or more than one. In the initial state, we will put an arrow before it, and to the final state, we will encircle it. Now, this graph can be represented mathematically, as I have told in previous video, that this automata be M. M equals to Q sigma delta Q0, Q1, because here the initial state is Q1, and F, where Q is the set of all states. It means Q equals to Q1, Q2 and Q3. Sigma is set of input symbols. So what are the input symbols are here? A and B. There are only 2 input symbols. And F is a set of final states. And here there is only one final state, Q3. So, and here we have mentioned that Q1 is initial state. Now we have to describe its transitions also. How can we describe it? To describe it, we will use transition function. See, see the first transition of Q1. There is one transition of Q1 and which is only for input symbol A. Delta Q1 A equals to Q2. Now define the transitions of Q2. Now Q2 has two transitions. One is for input symbol A and other is for input symbol B. What it does, on reading an input symbol A, it jumps to final state Q3, and on reading an input symbol B, it remains in state Q2. Delta Q2 A equals to Q3. So it is a graphical representation and it is the mathematical representation. Now how can we represent it in tabular form? This is the automata and now we have to represent it in tabular form. First of all, make a table. Right. In first column, describe only the states. Label this column with state. Right. Inside the table, mark the columns with input symbols. There are only two input symbols, so there will be only two columns. Columns of this tables are labeled with input symbols. Here label this with state, because here we write only the states. Now the rows are labeled by state. Q1, Q2 and Q3. Q3 is the final state, so encircle it. Q1 is the initial state, put an arrow before it. Now write the transitions of these states. Now the entry of this table will be the next state. Suppose in row Q1 and column A. In this entry, we will write the transition of Q1 on reading an input symbol A. On reading an input symbol A, machine jumps from Q1 when it is in state Q1. On reading input symbol A, it jumps to Q2. So here in this entry we will write Q2. It means from state Q1, when it reads A, it will jump to Q2. There is no transition for input symbol B. Similarly, write the transition of Q2. When it reads input symbol A, it jumps to Q3. When it reads input symbol B, it remains in state Q2. There are no transitions for final state Q3. So we can represent a finite automata in three ways. First is in graphical form, second mathematical. This is the graphical, mathematical and tabular form. Thank you very much.